Hey guys, welcome back to Mathematic Girls Party 3226. So, yes, first of all, a very happy new year. I wish you all the things that make you smile in this new year. So, I wish you a great success ahead. So let's get started with this video. You want to know which topic I'm going to cover. I hope you have already seen the name of the topic in the video itself. So yes, the topic is discriminant, right? A very important topic. When do we use discriminant? You have already heard about this word before. Let's understand about this word discriminant in brief, all right? So let's quickly get started with the videos. So first of all, let me share the screen and let me show you something, all right? Yes, so I hope my screen is visible. And let's start the topic. As I was saying, the topic is discriminant. So let's write down the name of the topic first. All right. Yes. So as you know, the topic is discriminant. So let's write down this word first. This topic first, discriminant. Now, this word basically comes when we talk about a quadratic equation. All right. Discriminant. Yeah. So yes, so this topic basically we talk when we talk about a quadratic equation. Also sometimes when we talk about a cubic equation. But in this video, I'm just gonna talk on quadratic equation. Okay, we'll understand about discriminant with the help of some formulas and uh, how basically discriminant is being used here. All right. So first of all, let's understand where do we use this. So this topic, this word discriminant is used in the case of a quadratic equation. We basically use this to find the nature of the roots. So through this topic discriminant, we are going to basically see some formulas. With the help of formulas, how easier it is to find the nature of the root. Okay, so let's get started with that. We are basically going to study the formula directly. So before telling you the formula, I just want to tell you something, that this is the standard form of a quadratic equation. Ax squared plus bx plus c equals 0. That's the standard formula. Standard form, not formula, standard form. So let me write down that also. So this is our standard form of a quadratic equation. Form of a quadratic equation. Now I'm going to write down a formula here. Okay. So to find the value of x here, we have a formula, and that formula is this: x equals minus b plus minus root over b squared minus 4ac upon 2a. That's the formula to find the root of this quadratic equation. This x is nothing but the root. Now, what will be the nature of the root? That we decide using this word discriminant. Now, you must be wondering, where is discriminant? Do you know that we have discriminant right here? This part that you can see, okay, that is written inside a square root, okay, that is written inside a square root. That is nothing but our discriminant. This is our discriminant, b square minus 4ac, whatever is written inside the square root. All right. So let's write down, first of all, what's the symbol. So here, this b square minus 4ac, this part is nothing but called discriminant. And there is a sign for discriminant. Either we represent it by a capital letter D, or we also represent it with this symbol. All right. Either capital D or this symbol. So we have a formula b squared minus 4ac. All right. This is the formula. Now, through this formula, we can find the discriminant of a quadratic equation. Now, let's understand about the nature of the root, how we can understand whether the roots are real or not real. Let's understand about this now. So first of all, let me just write down something here, that nature of the roots, all right? So yes, now we will be discussing on nature of the roots. Now, when I'm saying nature of the roots, I'm just trying to tell you that whether the roots will be real or not real. When I'm saying not real, maybe for you, it's just you can consider not real for 10th grade students. But for the higher grade students, you can consider not real. That means the roots are complex. All right. So here I can use this word complex as well. Complex is just the roots are not real. All right. So now we will be talking about the nature of the roots. All right. So when I'm saying nature of the roots, we have basically three cases. All right. The three cases are, the first one is when we have this discriminant is a positive, that means greater than 0. The second case, when this discriminant equals 0. And the third case, when this discriminant is less than 0. These are the three cases through which we will find the nature of the roots. All right. So when the discriminant is positive, that means d is greater than 0. The quadratic equation has two different real roots. All right. How many real roots? Two different real roots. That's the condition. So you can write down when d is greater than 0, then the quadratic equation has, we will take few examples also, don't worry. I'm just writing here the formula. The quadratic equation has two different real roots. All right. Now talking about when the discriminant equals 0, that means, of course, it is directly equals 0. In this case, we have two equal real roots, unlike discriminant is greater than 0. So in this case, we have, I can just write down, it has, in this case, it has two different real roots, but in this case, it has two same real roots. All right. Or we can say that it has a unique real root. It can be say one also. So it has same real roots. Right. So it's the only difference between both of them is that when the discriminant is greater than 0, it has two different real roots. But when the discriminant is equal to 0, it has only two equal real roots. All right. Two equal real roots or two same real roots. Both are almost same. Now, when the discriminant is negative, so in this case, we can say there are no real roots. All right. So for right now, I'm just writing also no real roots. All right, just a moment. Yeah. So no real roots, or in other words, we can say two different complex roots. When the roots are not real, they are also called complex. So if you are a 10th grade student, if you are in till 10th grade, right? You can be in 9th or 8th also. So consider no real roots. Otherwise, if you are in 11th grade or in 12th grade, consider two different complex roots. All right, complex roots. Let me know in the comment section if you want to understand about this complex number in detail, because absolutely I love this topic, complex number. So yes, let me know if you want me to make a detailed video on this complex number chapter. All right, so these are the three cases. Let me just do something for you. Yeah, let me put it in a bubble. Okay, so this was when the discriminant is greater than 0. This is when the discriminant equals 0. Oh, it's looking like a Indian flag. All right. So, okay. And this one is when the discriminant is negative or less than 0. Remember that do not get confused between discriminant and determinant. These are two different words. These are two different topics. I have seen a lot of students getting confused between these two words, discriminant and determinant. This is discriminant. All right. So what I said, a quadratic equation with discriminant d has three cases. All right. When the discriminant is positive or greater than 0, it has two unequal real roots, or we can say two different real roots. When the discriminant equals 0, then they has only same root or only one real root. And when the discriminant is negative or less than 0, it has no real roots, or we can say two complex roots, two different complex roots also, we can say. I hope it's clear. Now let's take one example and let's solve it quickly. So basically, with the help of this example, you are going to find the nature of the root. All right. So let's directly start with the question. So the question is, so we will be finding the nature of the root by finding the discriminant. All right. So let's write down the question. So the question is 2x squared, all right, minus 3x plus 8 equals 0. So we have to find the nature of this nature of the roots of this quadratic equation. First of all, let's compare this quadratic equation with the standard quadratic equation, standard quadratic form. So that is ax square plus bx plus c equals 0. Understand how do we compare, right? So here a is 2. B is not 3, minus 3. You have to consider the sign also, right? And C is 8, right? Now, directly, let's find out the discriminant. So, discriminant formula is B square minus 4AC, right? B square, that means minus 3 square, minus 4. A is 2 and C is 8. So, of course, this will become minus 3 square, that means 9, because minus is plus and 3 square is 9 and minus 4 into 2, 8, 8 into 64. Clearly, we can see that this is 9 minus 64. That means it is 55. Oh, minus 55, sorry. So it is minus 55. And what is this minus 55? This minus 55 is less than 0. That means we got the third condition, that our discriminant is less than 0. All right. Our discriminant is less than 0. So as you can see, the third case, when the discriminant is less than 0, the answer is it has no real root. All right. So for the 10th grade students or till 10th grade students, I'm writing, therefore, no real root and you are done. That's it. You can leave the answer here only. But if you are in 11th grade or 12th grade, you have to find the nature of the roots. That means the complex roots as well. So let's quickly understand this part as well. As I said, till 10th grade students, you can stop here only, no real roots. For the higher grade students, I'm just writing how to solve the complex roots. All right. So because you know the formula is x equals minus b plus minus root over b square minus 4ac, which is a discriminant only upon 2a. So let's solve this quickly. So minus b. Oh, let's write down the values quickly. Give me a moment. Let me, yeah. So b is, okay, let me do one thing. Let me write down these values below also. So a is 2, b is minus 3, and c is 8. Let's write down that. And yeah. So I'm going to write down those values here. Yes. So yeah, a equals 2, b equals minus 3. Let's put minus 3 plus minus root over b square minus 4ac. We already got this b square minus 4ac, that was minus 55 upon 2a. So 2a, that means a is 2, so 2 into 2 is 4. So we are getting minus 3 plus minus. This, I hope you know how to solve this. You have to write down this as minus 1 into 55, because yes, we can write down like this. And then after this, just a moment, let me go down. Yeah, upon 4, and then we can write down this as minus 3 plus minus root over minus 1 into root over 55. We can write down like this. All right, upon 4. Now this we can write down as minus 3 plus minus. I hope you know that here this root over minus 1 is nothing but our iota. I. We write down this as I. And this is root 55 as it is. And then I, where what is I? I is nothing but root over minus 1. So yes, if you want, I'll say this again. If you want me to make a detailed video on this topic, which is a complex number, let me know in the comment section. All right. And then upon 4. So yes, we can write down the two complex roots are minus 3 plus root over 55i upon 4. And the second one is considering the negative sign, minus 3 minus root over 55i upon 4. These are the two roots, complex roots we can say. As I already said that if you are in 10th grade student, you can leave the answer there only where I wrote no real roots. Otherwise, if you are in a higher grade, please proceed till this and you are done with this. So I hope with this video, you have understood this topic discriminant in a better way. Let's meet in the next video with a different topic and see you soon, guys. Thank you so much for watching my channel. Thank you so much for your support. Thank you so much for your love. But still, I'll say that if you're new to the channel, don't forget to subscribe to the channel. Thank you.